Hello, and welcome to Introduction to Azure Infrastructure as Code. This session is coming to you as part of the Azure Back to School event. My name is Carey Payette. I'm an Azure MVP, as well as a Microsoft certified trainer. During the session, we're going to dive into the significance of infrastructure as code, as well as how it fits into the CI/CD, or continuous integration and continuous deployment practices within a company. We're also going to explore a handful of tool options that are available that you can use when you're implementing infrastructure as code in Azure. So we're going to cover ARM, templates, Bicep, Ansible, Terraform, and Pulumi. My hope is that this session will equip you with a quick taste of each of these tools so that you can decide for yourself the most suitable approach for you and your company. Let's start with a quote that I feel really summarizes infrastructure as code. This is a quote from Raka Mahesha, an author at Payette. Infrastructure as code, also known as programmable infrastructure, is a process for managing computing and networking infrastructure using software development methodologies. These methodologies include version control, testing, continuous integration, and other practices. Let's talk about some of the benefits of infrastructure as code. Full SDLC tooling. So as mentioned in the quote before, because the infrastructure itself is modeled in code, the entire coding ecosystem applies to infrastructure as code, or IAC for short. This includes things like source control, DevOps, GitOps, CI/CD. So you have all of those tools that are available to you for your infrastructure, just as you would with your software. Infrastructure documentation and creation. As well as creating the environment, the code also acts as documentation and source of truth. So you don't actually have to create other documents that explain, the settings and configurations of your infrastructure. The code speaks for itself. So it's like having built-in documentation. Correcting environmental drift. Because code is going to be considered the source of truth, the IAC tool can also correct what's called environmental drift. So what environmental drift is that over time, each environment that you have deployed out to the cloud, or really deployed anywhere, becomes something what's called a snowflake. So essentially, there's iterative configurations that are made over time manually, and the original deployment artifacts are inconsistent with the actual environment as they stand today. So what that does is it puts you into a position where that current configuration cannot be reproduced automatically. It also causes inconsistency among environments and often leads to issues during deployments. So what an IAC tool, or an infrastructure as code tool, will do is allow you to define the desired state and configuration of your environment in code so that it will always be reproducible. Much along the same lines, you also have the ability to deploy identical environments. Again, because you're using code that is already defined, you have the ability to use that exact same code, throw in a few different parameter values, and be able to stand up new identical environments using the exact same code. Environmental consistency. Again, how many times have you seen where your dev, test, QA, production don't match? So consistency is key, especially if you're trying to troubleshoot performance problems, for instance. What environmental consistency does is IAC again gives you the ability to fire up environments that are identical to production-like environments, even if it's something like a SWAT, for instance, like you have some type of performance issue in production and you want to stand up an identical environment temporarily so that you can debug those issues. So you are able, again, using infrastructure as code, the DevOps team can go ahead and fire up a production-like environment automatically using infrastructure as code and any type of pipelines that you may have for your application release. Speed, this is a big one. So infrastructure as code, we like to think of as a force multiplier. So if you're like me and you've got a long history of going into the Azure portal and hunting and pecking each resource that you need, setting up individually and then going back afterwards and implementing the dependencies within the resources, you know that that is a time-consuming and error-prone process. With infrastructure as code, everything is automated. So the tools themselves can determine which tasks can be performed in parallel. So if you have like 18 different resources being deployed and there's only dependencies between 3 of them, the actual IAC tool will go in and start deploying different resources in parallel so that your deployment speed is sped up greatly. Another thing that you get with infrastructure as code is history and accountability. So because everything's being checked into a source control system, you always know who changed what and when. And the pipelines, when they ran, will also record who deployed the changes. So even if you don't automate a production deployment, you have the ability still to see, okay, who manually triggered that deployment. If it's automated, well, then you could see which check-ins or CI/CD processes were triggered in the process of doing that release, if you will. There's also lower infrastructure management costs. So the more automation, of course, equates to savings on both time and cost. So spending less time on manual configuration and management allows an organization to redirect professionals to higher priority efforts. So instead of manually accessing the portal to do all the work manually, automation is your helper, and then those professionals can be redirected to production issues, for instance. Now, something that I've iterated a couple times already is probably the one big adjustment when it comes to moving to infrastructure as code, and that is to rely on the code as being the source of truth. Using infrastructure as code tooling, you let the code dictate the end state of your cloud infrastructure, and not vice versa. So you might be thinking, well, in the cloud I have these resources deployed, so that's really what the truth is. But we really need to start flipping your mindset. So you want to start involving infrastructure as code methodologies. So you really want to flip that on its head and say, well, I want the infrastructure as code tooling to be the source of truth. Again, that's going to be acting as your living documentation. And you want that infrastructure as code, the configuration that is put within, to be the source of truth. Some of the benefits to having your infrastructure in source control. So again, single source of truth, I'm going to harp on that quite a bit. It has all of your infrastructure management concerns there, and it's documented. Every single one of your files is going to be version controlled. This also serves as built-in documentation, so you always know the desired state of your infrastructure. And because this is in version control, which is obviously very popular when it comes to software development, you can also use software development tools in conjunction with it, with your infrastructure as code. So you have the ability to go in and test and monitor your configurations. IAC is code, and like all code, it can be tested using testing and monitoring tools for IAC. There you can check for errors and inconsistencies in your configurations, and you can identify these before even applying them in production. So that's really the key here of CI/CD, is you want to make sure that you catch problems early. Another thing is because it serves as your documentation, the configuration files are dictating exactly the state of your infrastructure. You're able to have no surprises. You can actually go into your IAC code, identify what's included in each configuration, and then use like the Azure pricing calculator, for instance, to calculate what the cost of the infrastructure that would be deployed would be, or what the current costs are. Just as a recap, what CI/CD stands for is continuous integration and continuous deployment. And obviously this has been common practice in the world of software development for a very long time. But again, I want you to put in mind that infrastructure as code is essentially, it is software, it's code. So the continuous integration, continuous deployment cycle is where you will see infrastructure as code fitting in. So just as another quick recap here, we have continuous integration. That's the practice of frequently integrating code changes into a shared code repository, that version control. The goal of CI, again, is to detect and fix integration issues as early as possible in the development cycle, because you do not want to be surprised by some misconfiguration or some type of error in production when you deploy. So this is achieved by automatically building and testing the code whenever code changes are committed to the repository. Now, CD is the continuous deployment. So this is the practice of automatically deploying software changes to production or other environments. I've seen a lot of organizations that do automatic automatic deployments between like a dev and a test environment, for instance, and then manages manually the push to production. It's still automated, but they want to have a gate check essentially to be able to say, yes, all my tests pass, things are reliable, let's go ahead and move that. So the goal of CD, or continuous deployment, again, is automatically deploying software between environments, so dev, test, for instance, making sure that they've been built and tested. And the goal of CD, again, is to reduce the time between code changes and deployment, and to ensure that changes are deployed in a consistent and reliable manner. So together, CI/CD provides a streamlined approach to software development where changes are automatically built, tested, and deployed, reducing the risk of errors and improving the speed and quality of software releases. So this process involves using tools and techniques, again, using version control systems, automated testing frameworks, deployment pipelines, to ensure the entire software delivery process from code changes to deployment is fulfilled. So infrastructure as code, again, treat it exactly like you would software. The IAC code is checked into version control, and it's then built, tested, and deployed in the same way as application code. So this ensures that infrastructure changes are tested and validated before they're promoted into production. Again, reducing the risk of errors and downtime. When it comes to automating your CI/CD pipelines within Azure, you have a few different choices. Now, this is not an exhaustive list. This is just 3 of what I think are the most popular automation products available for Azure. So the first one, of course, is Azure Pipelines. Azure Pipelines, it integrates with Azure DevOps, supports a wide range of languages and platforms, and includes things like release management, deployment gates, and multi-stage deployments. GitHub Actions, that's our second one here. This is tightly integrated with GitHub. Again, it supports a wide variety of languages and platforms. It has reusable actions, workflow visualization, really good pros with that. Some of the cons with GitHub Actions is it is still a relatively new tool compared to the other tools. So, but the community is huge. So you'll see that the community is contributing reusable actions quite a bit when it comes to supporting GitHub Actions. So that is another option that you have to you. The third one here is Jenkins. So Jenkins is a very highly customizable product. It supports a wide range of plugins and integrations. It can be used both on premises or in the cloud. Some of the cons with this is it's not really the most easiest thing to configure and maintain. Some of the plugins that are available haven't been updated to. So there's a lot of outdated or unsupported plugins. But again, the community is there. You should be able to be fairly self-sufficient with the community added plugins that are available. So in general, Azure Pipelines is a good choice if you're already using Azure DevOps, while GitHub Actions is a good choice if you're using GitHub for source control. And Jenkins, of course, is a great choice if you need a high degree of customization and control over your CI/CD pipeline. So in a nutshell, we could spend an entire day talking about the features of CI/CD tooling. For this talk, however, suffice it to say that executing infrastructure as code from any of these products as a step in your CI/CD pipeline is possible. So you can have IAC tooling integrate with Azure Pipelines, GitHub Actions, and Jenkins. All right, let's get a little bit foundational. So when we're talking about infrastructure as code, when it comes to Azure, we're talking about Azure deployments and configuration. So how does Azure deployments work? So in the middle here, you're going to see this big block, and it's called the Azure Resource Manager. And the Azure Resource Manager is just that. It manages all the resources within Azure. Every resource that is created, destroyed, modified, configured is all orchestrated through the Azure Resource Manager. You're probably already familiar with how to deploy resources, so there's multiple ways of doing it. You can use the Azure portal, you can use CLI, you can use PowerShell, but really at the end of the day, it comes down to REST endpoints. So this little blue dot here, that is the REST endpoints for the Azure Resource Manager, and it really does not matter how you're interfacing with it, that at the end of the day, it all comes down to these REST endpoints. And because it's REST endpoints, this enables third-party software companies to interface with and provide custom tooling. And this is what gives us options when it comes to infrastructure as code tools. Now there's another layer here. So this right here, this is like that orchestration manager. It's the orchestrator. Now what you see down here, they do look like different resources, for instance. So here we have a storage account, right? But what's really not shown here is there's another level. So there's a level called the Azure Resource Providers. And what this means is that the Azure Resource Manager works using a provider or a plugin model. So this means that as services are introduced into Azure, a provider, so we're going to pick on the storage account here. So Microsoft.storage is the provider here, gets created that adheres to a common interface that the Azure Resource Manager can use. And the providers themselves are the ones, like that implementation, are the ones responsible for completing the requests. So the Azure Resource Manager will get a request, create storage account, comes in through here. The Azure Resource Manager will send a create request to the specific provider, which in this case is the Microsoft.storage provider. And that Microsoft storage provider will create the storage account. One thing to note is that when a new type of resource is introduced into Azure, that the third-party tooling support tends to be a little bit behind the implementation. And this is expected because they have to react to the different providers, the different settings, for instance, and implement its support for those new options. When you're dealing with infrastructure as code, what you're dealing with is essentially describing the end state of your Azure deployments. So the behavior of the resource manager is that it will try to create all resources that are specified in the deployment. So if the resource already exists and its settings are unchanged, then essentially it's a no-op. No operation is taken for that resource. If you change the property value for a resource, for instance, the resource will be updated with those new values. Azure Resource Manager will automatically detect dependencies between resources in a deployment as well. So when you define multiple resources, for instance, in an ARM template, The order in which the resources are deployed is determined by the dependencies between the resources. So the order that the resources appear in the file is not important. So for example, if you define a virtual machine and a storage account in your ARM template, the virtual machine depends on the storage account for its storage. So when the Azure Resource Manager goes to do the deployment, the storage account will be deployed first before the virtual machine, even if you have the virtual machine potentially defined first in the ARM template itself. The IAC tools that we're going to cover today work with Azure Resource Manager in what's called a complete mode. This means that the Azure Resource Manager will delete resources that exist in, like for instance, a resource group but aren't specified in the template. This way, if you want to remove a resource, so for instance, if you have 3 websites and you find out later that you only needed 2, in order to delete it, all you have to do is remove it from the IAC code file, and when the infrastructure as code tool runs again, the resource will be destroyed because it's no longer there. Another thing to keep in mind is if you don't specify certain properties for your resources, Resource Manager will interpret the deployment as overwriting those values. So properties that aren't included in the template are reset to default values. So what you want to do is you want to specify all non-default values for the resource, not just for the ones that you're updating. So that's just a tool to have in your pocket. Infrastructure as code, again, what you're doing is you're holistically defining your desired end state for your resources. So when IAC tooling is run, this end state is compared to the resources that are already deployed. So for example, let's say you have deployed an Azure App Service plan and an Azure App Service using IAC. And then later you also find out that you need a supporting storage account. So with IAC, what you do is you open up that same code, if you will, and simply add the storage account resource to your code. So you're not touching the things that are already there. So the app service plan and the app service. So when the infrastructure as a code tool is run, it will recognize that the app service plan and the Azure App Service are there and they remain unchanged because we haven't changed any properties. And it'll actually only go and deploy the new storage account. So this way you can still apply the same configuration multiple times and get the same result, which is the defined end state. Again, infrastructure as code allows you to holistically define that end state. You can apply that configuration 1,800 times if you wanted to, but as long as that end state is defined and it hasn't changed, then you're always going to result with the defined end state at the end of the run. Most of the tools that we're going to cover today support something called an import function. And this means that you can point the infrastructure as code tooling to Azure resources and have them generate code. So keep in mind that just because you might have existing infrastructure deployed doesn't mean that it's too late for it. You can start with infrastructure as code using these import tools. Starting small is essential if you're just starting your journey into infrastructure as code. So for your first project, I recommend choosing something that's small, simple, some type of greenfield project that's easy to manage. It's similar to things that you've deployed before. Bite-sized projects are ideal for learning because the end goal is typically well-defined and the team can focus on learning how to incorporate IAC instead of spending time trying to figure out solutions to complicated architectural problems with a more complicated system. Another thing to keep in mind is it's also beneficial to identify IT staff or consultants who have experience with IAC and can mentor and guide the process. Mentorship is important because just as it is in the software development world, we're all too familiar with the concept of what's called spaghetti code. It definitely probably does the job and does it well, but it's difficult to read and maintain. IAC code is code, so it's not immune to this type of problem. Luckily for us, the tools that we're going to cover today are module modular, and composable. So this means that large, complex architectures can be broken up and defined in smaller units of code, making them easier to read, maintain, and of course, reuse. I also recommend that with guidance, again, that mentorship, your company can look to adopt standards for code organization, naming conventions, reusable modules, some type of repository, for instance. All of this will increase your chances of success for current and future projects. Another thing to keep in mind here too is your choice of tool really does not matter. All the tools that I'm going to be covering today are good tools. What's important is that you look as a person and as an organization and see how each solution fits into the current and future goals and skill sets and choose the tool appropriately. For the remainder of the presentation, we're going to be talking about some of the infrastructure as code tooling options that you have available to you. But one thing that I do want to put in the forefront is that when you're dealing with infrastructure as code, you have a couple different options available to you. One is declarative, and one is imperative and procedural. So let's start with defining what does it mean to be imperative or procedural. So I like to think of that as more or less you're writing code to accomplish what you need. So like when you're using an SDK, for instance, you might use a .NET C# SDK that will create a storage account and 3 containers within it and upload 3 files. That would be C# code would be procedural. So you're creating the account, creating the containers, uploading the actual files that go in there. So you're looking at source code that is procedural. When we're talking about declarative, you're more or less you're defining the definition of what the environment is, not necessarily the how to do it. So when you're thinking of declarative, think about we'll talk about an ARM template here. You have a resource, you have a storage account, and a virtual machine. All you have to do in a declarative way is create that JSON file and set the properties for each of those resources. You're not telling the Azure Resource Manager, create this storage account first using this SDK with these properties. What you're doing is you're giving it a definition, and the Azure Resource Manager determines the how. Whereas in imperative, you're actually coding it. You're saying, Azure Resource Manager, create the storage account, create these containers. So that is the difference between declarative and imperative. So the preferred approach to IAC is typically to use a declarative way if possible. So the definition file, again, specifies the what an environment requires and not the how. So in other words, it may define the specific version and configuration of a cloud asset, but it does not dictate the process for installing and configuring it. This abstraction allows for greater flexibility, as it is the infrastructure provider that handles and optimizes the installation. It also helps reduce the technical debt of maintaining imperative code, such as deployment scripts that can accrue over time. The first type of IAC that we're going to cover here is ARM templates. The good news is ARM templates are always guaranteed to be up to date with the latest resource types available in Azure. So when you actually use the Azure portal to manually configure a deployment, ARM templates are actually being created behind the scenes to actually do that performing of the deployment. ARM templates are the native Azure definition of deployments. You also have the ability to export ARM templates. So again, this kind of goes back to the import functionality that we talked about earlier. You have the ability to go into the Azure portal, for instance, and select at the subscription, resource group, or resource level and export ARM templates for all of the resources contained. So that functionality is available to you as well. So some of the pros here, obviously it's native to Azure. It's well integrated with Azure services and Microsoft tools. It's easy to use and understand, especially if you are familiar with JSON it has excellent documentation. So some of the cons are it's a little wordy. So JSON by nature tends to be a little long in the tooth, if you will. So depending on how you have your code set up, it might be a little difficult to maintain. Modularization is also a little bit tricky. You do have the ability to break apart ARM templates into smaller pieces, but essentially the way that they're brought back together is by nesting them and essentially referring to them in other files. So it can get a little bit unwieldy depending on how complex your architecture is, I should say. There's also limited support for testing and debugging. So of course, you can use things like PowerShell and Azure Resource Explorer to go in and take a look and troubleshoot issues, but there's really not too much available to right out of the box. But there are some testing suites and things like that that are coming around that you could use as well. But anyway, so that is a quick look at ARM templates. So let's head over to the portal and see this in action. All right, welcome to the Azure portal. I have a resource group already created here, and let's go ahead and pretend we're going to create a virtual machine. So we're not actually going to do it, but I want to show you how you can see the ARM templates that are created for you. So let's go ahead and pretend we're creating a virtual machine. And we're going to, name this whatever we want. That all looks good to me. Let's go ahead and review and create. All right. So here we can see that we have our validation passed. But one thing that I want to point out to you is that whenever you are deploying resources within Azure, you have the option to download a template for automation. And this template will be the ARM template. So here you can see, similar to what we had on our slide before, we have a bunch of parameters, and then we have variables. And then of course we go into the resources that we are deploying as part of this virtual machine. So this is an ARM template that was created for us by the Azure Resource Manager. All right, let's go ahead and go back to our resource group. Another option that we have available to us is to actually bring in an ARM template directly into the Azure portal and deploy it there as well. So if you go into the search, and you can search for deploy a custom template. So you can say deploy a custom template. You can select that. And from there you have the ability to use some common templates, but you also have the ability to bring in your own. So you can build your own in the template editor. So here you can see there's the JSON that is available to us there. So if we wanted to, we can take an existing ARM template, just copy and paste it in there. You also have the ability to load files as well. But I can go ahead and paste that in. And then once I save that, you can see that now my custom deployment has the instance details, like the parameters, if you will, that I was looking to populate. So that is another approach to how to load an ARM template within the Azure portal itself. All right. So the next thing that I want to show you is that inside of GitHub, I have this extremely simple infrastructure as code static web app that I have defined, and it's really just an index.html file. And what I want to do is I want to use an ARM template to go ahead and deploy this infrastructure as code web application to a static web app inside of Azure. So with that, I have a Visual Studio Code open here, and I have an Azure deploy.json file created. So let's take a look at some of the resources that we're deploying here. So here we have deployment of type Microsoft.web static sites. And in there, we want to know the name of the web app, the location, any resource tags, and of course the repository URL and branch that the source code could be found, and the repository token. And this, I'm not going to pwn myself. I'm going to actually pull this repository token after I've done the delivery of this presentation. And then, of course, we have build properties. So we're telling the static web app where to find the app and the API for the application. Some of the properties that come in here are SKU and SKU code. So we're interested in the free tier here all the way. So that is there as well. So inside of here, there's actually a child resource as well. So the child resource here is the app settings. And I want to be able to add app settings to the deployment as well that's associated with my static site. And you can see that in order to accomplish this, I've created some parameters. So the parameters here are name, location, SKU, repository URL, branch, repository token, the app and API location, resource tags, and app settings. So those are all available to be provided either through the Azure portal if I loaded them there, or if I submit a parameters.json file. So let's deal with that one next. So here is the template. Templates can be reused. You can change the naming or the parameters, if you will, the values through the parameters.json file. And really what it is again is another JSON file. And the parameters will show you what values you're setting it to. So here I want to say I want to deploy that web application. I want you to name it Vanilla Static Web App ARM. I want it in East US 2. I want it on the free tier. Here's my Git repository. Here's the branch. Here's my personal access token for GitHub. Here's the app location. There's no API in this case, so it's blank. Here's the resource tags and the app settings that I want to deploy with it. So what we're going to do now is we're going to actually deploy this template through the CLI. So in this case here, I've already gone ahead and done an AZ login, and I've set my subscription to the one that I'm interested in. So the next thing I want to do is I want to create a resource group to contain my deployment. So ARM and Bicep both require a resource group to exist. So I'm going to go ahead and use the CLI and create one there. So there it is. It's gone ahead and done. So now we have these files here. We have Azure deploy.json, which indicate, again, declaratively what resources that we want to deploy. And I want to seed that with the parameter values in my Azure deploy.parameters.json. So let's go ahead and use the CLI to do this deployment. So I'm going to copy some code here. And you can see that I'm creating a deployment group. So I'm going to call it deploying a local template. You can name this whatever you want. It's going to deploy into the vanilla web app RG that we just created. It's going to use the template file of Azure deploy.json, the one that we already have here. And then it's going to use the parameters that are found in Azure deploy parameters.json. So let's go ahead and enter that. And it's going to go ahead and submit this template to the Azure Resource Manager to orchestrate the deployment. So let's go ahead and give this a second to run, and we'll be able to see its results here momentarily. All right, so I had paused my recording there, but it ran in 32.957 seconds. So let's venture back to the Azure portal and see exactly what happened. So let's go back to our Azure portal here. We have resource groups, and we deployed the vanilla web app RG. And here you can see that we have the vanilla static web app ARM. So that was the resource that we had deployed inside of our template. So let's take a look at that. So here you can see that it's gone ahead and it's deployed bluepond.azure staticwebapps.net. Let's go ahead and select that. And you can see that my HTML file is now rendering. So it says, welcome to Introduction to Azure Infrastructure as Code session. So this again is just the HTML that I have inside of my GitHub. Now, the Azure Resource Manager did an extra step. So what's really nice about static web apps is it has that CI/CD already kind of built into it. So because I provided that personal access token, Azure Resource Manager went ahead and created a GitHub action, which is essentially my CI workflow, if you will, that will deploy my static web app. So we can go ahead and take a look at that, and you can see that my GitHub action, which is YAML based, you can see that any pull requests on any push on main or pull requests on open, synchronized, reopen, or closed on main will build and deploy my Azure static web app. So I didn't actually have to code this. Azure Resource Manager kind of cyclically knew exactly what I wanted and did that there. So here, if I select on actions, you can see I did some of them yesterday, but today's is right here. So this was the last run, and you could see the CI process went through. You can take a look at each of the steps and the outputs of each of them. So essentially the CI flow is done automatically for you once you've done your ARM deployment into an Azure Static web app. So that covers how to deploy an Azure Static web app using an ARM template. Another thing that I wanted to show you too is the actual configuration was deployed as well. So if I select configuration here, you'll see that the configurations that I set inside of my parameters file are being set here. So we have my app setting 1, which is value 1, my app setting 2, which is value 2. And if we take a look back here, we can see that my app settings are there. And we could also take a look at the tags that were added, and you can see that the tags were added as specified inside of my parameters file as well. Bicep is a relatively new infrastructure as code option for Azure, and it provides a more streamlined and simplified way to define and deploy Azure resources. Bicep is a declarative language, allows you to define the infrastructure's code, and you can see that it's in opposition to JSON, it seems to be a little bit more clear, concise way. So Bicep is an open source project that is designed to improve the experience of defining and deploying Azure resources. It's built on top of Azure Resource Manager or ARM template language, but it provides a much simpler syntax and more intuitive structure. So some of the benefits include, obviously, the simplified syntax. It's definitely a lot more clear and concise versus hand tooling JSON. You have improved modularity, so it allows you to define modules that can be reused across multiple projects, thus making it easier to manage and maintain your infrastructure code. There's also better tooling support. So I'm using VS Code. You're going to see that there's full support like code highlighting, auto completion, error checking. It makes it easier to write and debug Bicep code. There's also support for conditionals and loops. There's also improved error handling. So there's more informational error messages that are provided to you versus what you would get when you have an ARM template that gives you an error. So it makes it easier to identify errors and make changes to your code. Bicep, however, is not immune to some of the drawbacks, including limited support for debugging and testing, as well as, because it is a relative new kid on the block, that the documentation is also a work in progress. All right, let's take a quick look at Bicep. So there's actually a really cool website called Bicep Playground. So bicepdemo.z22.web.core.windows.net. And it allows you to actually load existing ARM templates and have it converted into Bicep code. So let's go ahead and do that. So let me just zoom this in just a little bit. So let's go ahead and select decompile, and this will allow us to select a piece of code. So I'm going to select Azure deploy.json here, and it's going to go ahead and load that. And you can see that we've actually grabbed the ARM template that we had defined in the previous one. I have some of the naming that's changed just because I want to change the naming with what we deploy from Bicep, but essentially it's the same JSON ARM template that we used in the first demo. And here you can see that we have the resources defined and the parameters. Now on the other side is the generated Bicep code. So this is a domain-specific language, or DSL, that hosts Bicep, or that it's a Bicep DSL. But essentially you can see that it's a little more programmatic. So if you're a programmer, you might be more at home looking at code that looks like this versus, for instance, looking at straight JSON files. So here we can see the code that was generated for us here. Now, I've gone ahead and I've loaded that already into my Visual Studio Code. So let me bring that up here. And here you can see that we have syntax highlighting and error checking and things like that. But you can see that it's a much more clear and concise way of defining how to deploy my static web app in this case. So we're going to go ahead and deploy the same one here. So the first thing that we're going to do is we're going to create a new Azure resource group to contain it. So let's go ahead and do that. We're going to be using PowerShell commandlets to do this. So I'm creating a vanilla web app Bicep RG this time. And in order to deploy the file, it's much similar to what we did for the regular ARM template. It's actually quite similar itself, but I'm going to paste it in here. We're going to create a new Azure Resource Group deployment. We're going to call it Vanilla Azure Bicep Deployment Resource Group, and the one that we just created, which was the Vanilla Web App Bicep RG. And we're going to use the template file of main.bicep. And then we're going to send in the parameter file of Azure deploy parameters.json. So even though we do have parameters defined here, the parameters.json, obviously it's still a JSON file, but you have the ability to overwrite the values that are in the main.bicep. So these are essentially what you would consider defaults here. But you can see the application API location resource tags and app settings. They are defined in a much clearer, concise manner. So let's go ahead and deploy that. So what it's doing now is it's going out and checking the ARM template to see what may already be deployed. And if it's some of this code has already been deployed, the resource state will be pulled in, and then the differential will be taken. In this case, we want to create these two resources. One is for the vanilla static web app, and one is for the app settings resource contained within. So I can say A for all. And now what it's going to do is it's going to submit to the Azure Resource Manager this template. So it was a very quick deployment here. So you can see that it's gone ahead and provisioned those things. So if we go out to the Azure portal now, we can go into our resource groups. You'll see that we now have a vanilla web app Bicep-RG. And we'll give it a second here to refresh. Sometimes the Azure portal doesn't refresh right away. Another way to go to it is actually going into the deployment and looking at the details. So if you need to get to a specific resource itself, you can go into it through there. So here we can see that we've deployed Whitestone 06 blah 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 dot Azure Static Web Apps.net. Now in between the demos, I actually went and I deleted the workflows directory because the Azure Resource Manager will create new for each one. This is just because it's a demo and I'm redoing it each time. I wanted the actual Bicep deployment Azure Resource Manager instance to deploy its own workflow. So if I actually refresh this now, you'll see that the Bicep process, like that deployment went ahead and created a workflow to deploy. So if I select this one right here, which is our Whitestone, you'll see that we have our Welcome to Introduction to Azure Infrastructure as Code session page come up. So that is how we deploy that. And of course, the configuration is also going to be deployed. There's my app setting 1, app setting 2. You can see value 1, value 2. And of course, on the overview, you can see the tags that I added to the Azure Static Web Application. Now, because this one deployed so quickly, what I want to do is kind of demonstrate how to make a change. So in this case, let's go ahead and go into our parameters.json, and we're going to add an app setting 3. So let's go ahead and add a comma. We're going to say my app setting 3, and I can set this to the value of hello. So now I've gone ahead and I've changed the actual parameters going in. So I'm changing a setting within my Bicep deployment. Now what I can do here is I can go ahead and reapply it. So what it's going to do now is it's going to pull back the existing state of the resources, of which we already have the static web app deployed, as well as some of the app settings. So what it's going to do is pull it back. Now, Bicep is smart enough to see, okay, well, we're adding a different change to our resources. So we're going to be modifying the app settings here. So here I'm going to say yes. And then it's going to go ahead and deploy my new app settings. So now if I come back into my vanilla static web app Bicep, we should see that my app setting 3 is here, and we have hello. So because of the nature of the holistic approach, even though all the resources are defined within that Bicep template, the state is actually pulled out back at runtime, and only the differences are going to be added into the deployment. So that is how that works. Ansible uses a declarative language called YAML to define infrastructure resources and configurations. So these YAML files are called playbooks, and a playbook will outline a series of resources and actions that need to take place. So some of the attraction to Ansible is its simplicity. It uses simple syntax that's easy to understand and write, making it accessible to users of varying levels of experience. If you're knowledgeable of a lot of the CI/CD pipelines, a lot of those are YAML based as well, so it's kind of like reusing some of those skills as well. Some of the flexibility, it can be used to manage infrastructure in a variety of environments, so it's not limited to the cloud. It could include on-premises and hybrid environments as well. It's also known to be highly scalable. You can use it from a single server to large complex environments. It handles it all. Reusability, so there's Ansible roles and playbooks. They can be reused across multiple projects, making it easier to manage and maintain your infrastructure code. Some of the drawbacks, though, is you're not going to find full support for all Azure resources. So case in point, in this demo, what we've been doing all along so far is deploying Azure Static Web Apps in the demos. Ansible does not have a module to support this, so instead, in the next demo, what we're going to do is deploy an app service plan and an app service. Another thing is Ansible is Linux-based, so it needs a Linux-based controller node or runner in order to run. But you are able to use, as you'll see here in a moment, the Windows subsystem for Linux, or WSL2, and we'll go ahead and jump into a demo now. All right, what you see here is an example of an Ansible playbook. And you can see we're deploying an Azure web app from GitHub. We have variables that are defined as well as the tasks associated with it. So some of the tasks are create the resource group, create the Azure App Service Plan, and create the Azure Web App. So you can see here, again, it's fairly straightforward. It's using YAML syntax. There's not really much complexity to it. I find it very readable. So in order to actually run this playbook, you'll see that I'm in a WSL command line here, and I've already set up a service principal within Azure so that my deployments run under a service, like authenticated service principal, if you will. So I've already exported those values, so this WSL command line is already set up with the proper authentication. So in order to run this playbook, what we do is we say Ansible-playbook Azure deploy.yaml. So now it's going to go ahead and play that, and you can see each task is going to be executed in order. So we have our create resource group, create app service plan. Now we're creating the Azure web app. So if I am to go over to Azure right now, you should see that these values are provisioned. So let's go to resource groups here, and let's go ahead and refresh that. And it's not quite there yet. Oh, there it is. Vanilla Web App Ansible RG. And you can see that we are just waiting for the portal to update with our resources. You can see that our vanilla static web app Ansible plan is already there. And then momentarily we should see the actual web app show up as well. So I'm going to go ahead and pause it for that to show up. All right, so now you can see that we have our vanilla static web app Ansible pulled up. So that is how we have deployed our Ansible code. And when we go back to our Azure or our Visual Studio Code, you can see that all these tasks have played, and then we have a play recap that said that we have essentially added 3 resources into Azure. Next up, we have Terraform, and it's another flavor of declarative infrastructure as code. It uses what's called HCL, or HashiCorp Configuration Language, and as you can see from the screenshot on the right, that it's very easy to understand the resource definitions and how they interrelate to one another. Another great benefit to Terraform is the strong community support. Terraform is actually my tool of choice, so when I am actually developing infrastructure as code, Terraform is my tool of choice, and part of the reason is because of that strong community support, as well as the great documentation that is available and the training that is available as well. So they actually have free training as well as certifications that you can take. All right, so here is an example of Terraform that is deploying an app service plan and an Azure Linux web app to Azure. So again, kind of back into the third party, not always having the best support for resources. The Azure Static Web App will essentially deploy the web app, but doesn't hook up any of the CI/CD with the repository. So for this one, we're going to go back to the app service plan and the Linux app and deploy from there. So here you can see that we have a resource group that we're creating, and it's going to be populated based off of different variables that are passed in. So we have a variables.tf, and tf is the extension for Terraform, and you could see the values that we're passing in here. Now, these variables can be overwritten at runtime by using an auto.tf-vars file, so you don't actually have to check in like any secrets or anything like that into code. So here you can see that we're going to deploy a resource group. We're going to deploy a service plan, a Linux web app, as well as the source control associated with the Linux web app. So in order to get started with Terraform, what we would say is Terraform init. And what that's going to do is it's going to initialize Terraform. Now, there's multiple plans and validations and things like that that you can take a look at for the actual SDLC, if you will, of Terraform. But in our case, we're just going to go directly to apply. So let's just say Terraform apply. And what this is going to do is, again, it's going to query with the Azure Resource Manager, finding out the resources that we have deployed in the cloud. Obviously, this one isn't deployed yet, so it's going to come back with create resource plan. So here you can see that it's telling me and outlining exactly what resources don't exist, so we need to add them. And then to add them, we just say yes. So now what it's going to do again is it's going to take the configuration that I have defined, and it's going to pass that into the Azure Resource Manager and deploy those resources. So I'm going to go ahead and pause the recording while it does its thing, and then I'll come back once that's done. All right, so you can see that we have the resource groups already been created in the service plan, and it's currently deploying the web app. So we can actually go out to the portal right now and take a look at what's being deployed. So let's go into our resource groups, go ahead and refresh that, and you can see that we have our vanilla static web app, Terraform. Obviously, we're not doing a static app in this case, so it's a little bit of a misnomer, but you can see that we have our plan as we had defined deployed, as well as our web application. So that is how that one works. So let's go ahead and come back here. I'm actually going to interrupt this, which is fine. I just want to show that in order to restart, if you will, I can actually say Terraform destroy, and it'll actually grab the current state of the resources specified again in my configuration here and destroy them appropriately. So it's going to go pull the state, and then I'll be able to execute a destroy, which is essentially clean up my environment. All right, so now it's asking me if I want to destroy these things, and I'm going to tell it why yes I do. And Terraform will actually go out and delete those resources for me. So I don't actually have to go and manually delete those. And a lot of the tools that we've covered today also have similar functionality. I just wanted to show that the Terraform resources were destroyed. And inside of the Azure portal, if I refresh my resource groups, you can see that Terraform is no longer existent. All right, the last stop of the day. For the last stop of the day, we're going to cover Pulumi. Now, Pulumi is generally considered to be an imperative or procedural infrastructure as code tool, although it does have declarative features, such as like when you're defining your resources, for instance, those typically come in the shape of higher level constructs like classes or functions. But one thing to note here is it primarily operates in an imperative manner. So this means that you define specific steps and dependencies in your code, and Pulumi executes those steps in order to reach the desired state of the infrastructure. When you're defining your infrastructure in Pulumi, you have multiple languages to choose from. So this is really for those that are developers at heart or really enjoy specific programming languages. So you have the ability to use Python, JavaScript, Go, .NET, which includes things like C#, F#, VB.NET. You also have the ability to use Java, or even if you wanted to go back to YAML files, you also have support for that inside of Pulumi as well. So let's go ahead and jump into our final demo. I went ahead and I scaffolded a Pulumi project using .NET and C#. And you can see that the Pulumi tool went ahead and created just a regular .NET CS_proj file. So I named it Vanilla Web App Pulumi. And the actual scaffolder went ahead and created the YAML file here. But what we're really interested in is program.cs. So this is where the resources that we deploy are going to be defined. So the first thing that we're going to deploy here is a vanilla web app Pulumi-RG, and that's going to be a resource group. So the resource group is all in the namespaces for Pulumi themselves. So you can see that they're creating a resource group with the location of East US 2. The second resource that we're going to create is the Azure Static Web App. So we're going to go back to the model where we're deploying an Azure Static Web App that is sourced from the GitHub repository that I have inside of my personal GitHub. You can see the repository token here. Again, I'm going to be revoking that once this is done. And then, of course, the build properties telling it where to find the source code and the APIs if necessary. And then, of course, we're going to deploy this using the free tier of the Azure Static Web Apps. So in order to get started with Pulumi, what I have to do now is run build on the project. So I'm going to say .NET build. And you can see that the build has succeeded. The next thing I want to do is move those resources up into Azure. Now this CLI, I've already done an AZ login and I've set the subscription, so I'm completely authenticated on the CLI at the moment. So Pulumi is actually going to backpack on that authentication. So I'm going to say Pulumi up. So it's going to ask me to do a new stack. I'm going to say this is dev. And it's going to go ahead and, again, take a look to see if there's any existing resources that I may have already deployed. I do not have that. So you can see as part of my dev stack, what it's going to do is create the resource group as well as the static site. So those are the two resources in Azure that are going to be created. So I'm going to tell it to go ahead and perform that action. And it's going to deploy my resource group as well as my static site. So you can see the resource group is already there and the static site is there as well. So if I come out to the Azure portal now and I refresh my resource groups, we should have Pulumi show up here in a moment. There we go. So there's vanilla web app Pulumi. And inside there we have our vanilla web app. So if I select this, you can see that we haven't received any content yet, and that's not that's not the end of the world, because probably what's happened is as you remember, the ARM template goes ahead and creates an action and executes it. So if I go to the actions, we'll probably see that it's still running here. So of course the content hasn't been moved from GitHub into the static web app yet. So that's why it's not quite there yet. So we'll just give that another moment. But what's really nice about Pulumi is if you already are a developer, that being able to use the source language that you're used to goes a long way in helping with any learning curves. So let's go ahead and take a look at Victoria's Smoke. And you can see that my index.html is fully rendering. Now, similar again in to most of the IAC tools, I can also say Pulumi destroy, and it'll go ahead and destroy the items that I have deployed. So it's going to say, do you want to delete these items? I'm going to go ahead and say yes. And it's going to go out to Azure Resource Manager and destroy the resources in turn. All right, so let's go ahead and give this another second, and we should be able to verify that the Pulumi RG is destroyed. There we go. Let's go ahead and refresh that, and you can see that it is now gone. Thank you for spending some time with me reviewing how to get started with Azure Infrastructure as Code. I hope that you take away how infrastructure as code fits in with source control and CI/CD processes, and also come away with a taste of some of the various flavors of tooling that are available to you. So feel free to reach out to me anytime. Thank you again for spending your time with me.